Hello and welcome to 2D Arrays, lesson 207. So the concept today is to try and build this idea of, instead of a linear path, a two-dimensional table, if you will, or chart that we could use to populate information. Here we get a little example on the side of a chart where we've got different students and different weeks. So it's kind of like a gradebook scenario. And you probably have strong enough chart skills where if I asked you to find out the data on student 2 in week 3, you can read a map, so you understand how to go down to student 2, you know how to go over to week 3 and say 89. Pretty straightforward stuff. Note, to make it a little bit more computer sciencey, I've had us starting at 0 on the week and have us starting at 0 on the student. Student 5 week 1, you can come down to student 5 week 1, you get a 65. This is essentially reading a two-dimensional array. Our two-dimensional array, I'm calling it grades. You could think about this first student as the first parameter, the second week as the second parameter. So you can actually read that as grades student week, and that can find out any information about any single spot on this array. To generalize it even more, we could refer to it as rows and columns. Rows and columns here follow the exact same context that you learned about matrices in algebra, where our rows are coming down this side. That's what row you're on going across, like at a stadium or an arena. Column is up and down, like ancient Greek, Doric, and Ionic, and all those fun things. Here's what it looks like as code. So I've got my regular main. I made int bracket 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 because I want to make a 2D array. And this is an example of an initializer list. Now, an initializer list at first looks really daunting because it's just like a wash of info. But the trick is you want to have one set of braces for the entire thing. And then within that set of braces, you have a brace and then your first row, close brace, comma. Brace second row, close brace, comma, and then go all the way through. And that way you can populate your entire 2D array straight off the bat if you wanted to. If you want to access information, you can just say the name of the array, its row, its column. And you say what's in 0, 0, 2, 4, so on and so forth. Populate it just like normal. You can take a number and just put it into that spot. So that I'm taking grade table at spot 5, 3, and I'm overwriting that with a 99. So that's 1, 2, 3, 4, 5, 1, 2, 3. I'm overwriting that 87 with a 99. I can do math with it just as if any other variable, just like I do with an array. It's the same kind of idea. So let's say you want to make one of these bad boys. Then you want to instantiate. To instantiate, you say the type that it's going to hold. These are both int examples, but you could do anything you want. You could do a string, you could do an object, whatever you want to put there. Give it a nickname, equals new, same repeat there, and then the number of rows and the number of columns. Second example here is just showing us that we could do it with a double. It's also showing us that if you wanted to, you could actually interact with the user in these brackets. You could call a method that you have, or you could call a method to ask the user for information, anything you might want to do to populate those two numbers. You could put a variable there, anything you might want to do. All right, so this is kind of the classic algorithm that you want to be very comfortable with when working with a 2D array. This nested for loop allows you to visit every single spot of the array. So our outside loop is going to control our rows. R equals 0, R is less than data length R++, and that's going to control this first R spot when we're accessing the data. Sometimes you'll see people refer to this as I and J. That's kind of the classic variables that are used, but I find R and C to be a little bit more descriptive to find yourself what's going on. Running through this, I've got my R's running all the way through. Now note, data.length is referring to the number of rows of my matrix. So that dot length is actually going to be the up and down, how many rows does my matrix hold. If I want to know how far over to go, I actually have to say data bracket 0 dot length. That's like the width of my matrix. So that's how many columns I have going from 0 up. Data R, C, IO.get in. So this is basically one way to populate your array. So if you just made it blank, it defaults to null. You could cycle through and then ask the user for all the info. For testing purposes, this is probably not a great way to get yourself going. It'd probably be easier to use the initializer list, but in reality, you probably don't know every number in advance. So it might be some scenarios where it makes sense to ask the user for data. All right, so here we got a little bit of example, and we're going to play around a little bit with writing our own code to be able to interact with it. So what do we got? We have a main. In our main, we're creating this table which has 5 rows and 3 columns. So that's 5 across and 3 down. we've got 2 for loops to be able to run through the rows, run through the columns, and I'm going to each time take the row raised to the c power. So I'm going to get 0 to the first, 0 to the second, 0 to the third, and then I'm actually, would it even go that high? No, I'd get 0 to the 0, 0 to the 1, 0 to the 2. Then the next round is going to go 1 to the 0, 1 to the 1, 1 to the 2, 2 to the 0, 2 to the 1, 2 to the 2, all the way through and generate that. Notice the fact that I had to do a cast because math.power returns a double, but my array is of type ints. So I had to cast that to an integer before I could store it. And we got some methods underneath. The first thing we're going to do is provide a method that says print chart. And this is going to take in a 2D array, and I just want to show its contents. Probably a good idea just to grab this nested for loop that I've already written and throw that in there so that that's all going to work great. I just have to change table to data because that is my parameter that I'm passing in. And then instead of populating it by actually putting information in, I want to print. So I'm going to say system.out.print. I don't want to do a print line because I just want to get that data in there. Then I'm going to say data at bracket R, bracket C. That'll get my information. And then maybe I'll just throw in, oops, this tablet likes to jump on me. And then boom. Now, right now, that's looking good. I'm going to get that particular row is going to go all the way across. My only issue is I have no new line, so I'm just going to get my entire 2D array all across in one row. To do that, I'm going to sneak in a brace here, sneak in a brace afterwards, and say after I run that for loop, I now want to do a system.out.print line. I don't really care what I print, so I'll just do a double quote in there. But that way I'll get my line advancement to go down to the next level. So again, it's that same classic algorithm of that nested for loop, and then it's just interacting with it a little bit. Also note, I didn't need braces on the inside for loop because it's only a one-liner. But by adding the system.out.print line on the outside one, I needed it in there. Note, if I had forgotten that, then that would have been a logic error, and it still would have compiled. I would have had all my data on one line and been wondering what happened. All right, so the next thing we're going to do is we're going to sum up a chart. So I'm going to keep that same for loop because that's pretty handy. And this time it's called grid. They're all going to end up pointing to the exact same 2D array, but I'm calling them different things just to try and drive home the point that they can be different things. And I want to figure out what every value in the 2D array adds up to. So to do that, I'm going to need a variable to be able to store the result. So I'm just going to say sum. I'm going to have that equal 0. Inside the for loop, I can now say sum plus equals, and I just want to access the value of the grid. So grid bracket R bracket C. And now I'm going to get what they all add up to. Once it's all said and done, I'm expecting a return type, so I'm going to have to return sum. And then I'm all good. All right, we got one last thing to look at here, and that is a weirder scenario. At the end of the day, Java does not really believe in a 2D array. It doesn't have a 2D array anywhere stored in its memory. The concept of a 2D array is, in reality, an array of 1D arrays. This initializer list, essentially these outside braces, we're forming an array, and then for the first value of the array, we put an array in there. So in reality, there's no such thing as a 2D array. It just happens to be an array of 1D arrays. You could easily make an extension and have one array of 2D arrays, thereby creating a 3D array. And there's no limit to the max of it. I even had one student many years ago who was horrible at Hangman, but he was a good coder, and he decided that it made a lot more sense to try and write a program to help him guess answers based off what letters were there. And the most natural course of action that he could come up with was a 26D array. A 26D array for each letter of the alphabet, essentially. And then that letter of the alphabet would map to the 25 other letters of the alphabet. So he had this monstrous array. And Java absolutely let him do it. It just ran like molasses. It was so slow that it wasn't at all functional, and he realized that he probably could come up with a better system to come up with his answer. So Java lets you go as big as you want. It just might not be functional. But I digress. A ragged array is a 2D array, but each level of the array has a different width. That's the concept of it. So the first example we did, that grade book, it was a rectangular array because the number of columns was the same for each row. In this ragged array, I've got 3 rows, 0, 1, and 2, but the width of each row is different. Technically, this is possible. Java has no problems with it. As humans, it's a little bit weirder to work with, but it can be done. In that same scope of weirdness, it is possible to take a row out of the array and swap it with a new linear array. That's possible. Again, it's not something you might be likely to do, but it can be done. So it's going to change our loop just a hair. We still have this outside loop, the row 0 is less than length, row plus plus. That's pretty much identical to our old system. They opted to have the new line above the for loop instead of the below the for loop like I did last time. This next line's the one that's a hair different. C is going to equal 0, C is less than uneven row dot length. This row is what's different from our old algorithm. In our old algorithm, we just called that uneven bracket 0 dot length because all rows have the same width, so there's really no need to specify. In this one, you have to specify which row you're on so that it can grab the proper length. This is new to the AP exam as of 2014, so be a little bit careful if you encounter any of these in the multiple choice because they might still be working out what is proper difficulty. All right, enjoy programming Bomber.